Hello, everybody. Today we're going to talk about food preservation technology. When in your on your Google Classroom, it talks about thermal preservation. When you hear the word thermal, most of the time we think heat, but thermal really refers to temperature. It could be cold temperatures, it could be warm temperatures. So using temperature to process food in a different way. We spent a little bit of time talking about um, heat thermal preservation. We talked about canning. We also, in food science, if you took that class, we talked about food safety and how important it is to keep foods out of the temperature danger zone, which is 40 degrees to 140 degrees Fahrenheit. So today, when we talk about thermal processing methods, we're going to talk a little bit more, focus a little bit more on cold processing methods. So we're going to start with freezing food. In the 1920s, the food industry was really born. That's when this became a big business. And the 1950s were a time of huge change in the food industry because of the TV dinner. No one back then would have understood or could have understood the impact that the TV dinner had. But think about this meal here. Prior to TV dinners, frozen TV dinners, families made all of their own food by scratch, from scratch. They made it at their homes. When the TV dinner came out, this was a revolutionary thing for families. They thought it was exciting to be able to buy this little tray with the food already made. It saved time. My grandparents, I grew up going to their house and they had TV trays, little portable trays that they'd flip open. And that came about because of the TV dinner. They'd sit and eat their TV dinner and watch TV. So, a little bit behind the science of freezing. Freezing preserves foods by slowing down the action of enzymes. Enzymes are what cause foods to spoil and go bad. Enzymes cause food to change color, to become something different, and freezing slows that process way down. Some foods are blanched prior to freezing, which denatures the enzymes. That means that it kind of makes the enzymes fall apart. Blanching is simply putting food in boiling water for a period of time. So, like when I grow green beans in my garden, I blanch them before I freeze them, or broccoli, any of those things. I'll put them in boiling water for a couple of minutes, depending on the vegetable, and rinse them in cold water and then freeze them. This process of freezing doesn't kill microorganisms. It just causes them to become inactive. They slow way down in their metabolic processes and they don't really grow or live, or they don't grow or change during that time. When a food is thawed out, the microorganisms kind of come back to life. It's almost like they're dormant during that time. Freezer burn. We've all opened something up out of the freezer and seen this, this icy attachment to our food. Freezer burn is usually caused by poor packaging or something being in the freezer way longer than it was intended to be in the freezer. A brownish or gray color usually kind of appears in the food. The food appears dry. Freezer burn produces an off flavor and a tougher texture. What it is the result of, the food has lost its moisture when it's been exposed to air, and the moisture accumulates somewhere else in the food. So freezer burn doesn't make it unfit to eat. It just makes it not taste very good and not look very good. Commercial freezing methods, big companies use quick freezing methods to freeze their food. This causes the ice crystals to be smaller and results in less damage to the cells. So different ways that they can do this, they can use freezing in air, which is the most common. This is what we use at our houses in our freezers. Indirect or contact freezing, the food is placed on belts or trays and a refrigerant circulates through a wall beside the food. So the refrigerant doesn't come in contact with the food, but it circulates around it. Immersion freezing, the food is submerged directly in a non-toxic refrigerant, like you see there in the picture. Another method is freeze drying. This is when the food is frozen and then it's treated to remove the solvent, which is usually water. It's a process called lyophilization. A couple big words here on this slide. Sublimation is when water in the form of ice is removed. The ice changes directly to a gas and it kind of evaporates. Freeze drying is convenient and lightweight. It's used in a lot of foods indirectly. As an example, if you bought a boxed muffin mix, the strawberries or the blueberries that are in that muffin mix were probably preserved using freeze drying. If there's real fruit in cereal, like strawberries sometimes or bananas, those were probably freeze dried. We do see freeze dried fruits more commonly now. You can buy little packages of them. My daughter loves them, but it's about $4 or $5 for a little pouch of freeze dried apples or bananas. Irradiation, this kind of relates back to our nuclear fission discussion last week, and that's why I wanted to move in this direction next. But irradiation is something that we don't hear about a lot, but it's been around for over 20 years. It's a process where the food is exposed to a controlled amount of radiation for a specific time to destroy the microorganisms that would normally cause spoilage or cause foodborne illnesses. The food is said to be completely safe afterwards, according to the US government. This process hasn't caught on a lot because the word radiation and doesn't usually go with food. People don't really want to consume something that has been irradiated, even though it's been proven to be very safe. It's a concern for people. The waves of radiation actually break apart the DNA essentially, so that the bacteria can no longer survive. 1/4 to 1/3 of the world's food supply is degraded by pests, bacteria, resulting in food spoilage. We waste a lot of food because of this, and a lot of experts think irradiation could solve a lot of those food waste issues. It would make food last longer. It would make food safer. Essentially, if food was irradiated, you could take raw hamburger and eat it without any worries of being sick. Not sure why you'd want to do that, but irradiation really controls the safety of the food. So there's energy from radiation that's transferred in the form of waves. The more radiation, the greater the preservative effect. 1 kilogram of radiation would keep fruit from maturing quickly. 3 kilograms would kill microorganisms like salmonella. Irradiation was used in the 60s on potatoes and onions. Does the food give off radiation? No, the energy is not enough to split atoms, which is how radioactivity is produced. That's kind of going back to what we talked about last week in nuclear fission. Does it affect the food quality? Most people, there have been taste tests done, and most people can't tell the difference between irradiated food or regular food. And is it safe for workers? Yes, people are exposed to more radiation in an X-ray than when they're irradiating food. The FDA regulates irradiation. They put a symbol called the Radura on the food or nearby so that people know that it's irradiated. You're going to do a web quest relating to irradiation as an assignment this week, and you'll learn a little bit more about what foods actually can be irradiated and what you could buy in the United States that's irradiated. We're also going to spend some time coming up here on packaging food. It's such an important topic. If food is packaged properly, it minimizes food waste tremendously. So packaging food is done for safety reasons, to keep food safe for us to consume so no microorganisms are growing. It's done to preserve food quality. It's done for convenience. A lot of these packages are designed so that the food is very stackable, or it's able to put in your cupboard well. Expense is important with packaging food. Companies don't want to waste a lot of money on the package that the food comes in. They're also looking to do things in an environmentally safe way. We want packages that are going to break down quickly in landfills and not pile up. And packaging is there's also concern about marketing appeal. The packages draw you in and get you to buy a product. So we'll talk about this more next week, but modified atmosphere packaging, or MAP, is something that's used in a ton of foods to create a longer shelf life. So the air inside a package is replaced with a mixture of gases like oxygen, carbon dioxide, and nitrogen, and it makes the food last longer. So if you think about that bag of shredded lettuce, or you can see here like pork loins or other meats, the tub of hamburger patties that you get at the grocery store, all of those things have had a mix of gases injected inside the plastic packaging to make that last longer. So we'll come back to packaging next week and spend a little bit more time on that. So I hope you learned a little bit about different food preservation technologies and how thermal processing is used to make food last longer, and have fun learning a little bit more about irradiation this week.